Hi everyone, we are group J-10 and the topic for our presentation is use of address bus, data bus and control bus in the one Neumann architecture. I am roll number 53, Aryan Konde. Before getting into the architecture itself, let's know a bit about John von Neumann himself. He was an American-Hungarian mathematician, physicist, computer scientist, engineer and polymath. So, the one Neumann architecture is a model which is also known as the Princeton architecture. It was published in 1945. It is a design model for modern computers which has a central processing unit and the concept of memory, which is used for storing both instructions and data. This architecture implemented the stored program concept in which data and instructions are stored in the same memory. This comes with a slight drawback because an instruction fetch and data operation cannot occur at the same time, which is called as the von Neumann bottleneck. This tends to reduce the performance of the system. So the one Neumann architecture is also called as instruction architecture, and it has three basic units, them being the central processing unit (CPU), the main memory unit, and the input-output device.
So the first unit of basic structure is central processing unit. The central processing unit is defined as it is an electric circuit used for executing the instruction of computer program. It has following major components: the control unit, arithmetic and logic unit, and the variety of registers. Control unit. A control unit handles all the processor control signals. It directs all input and output flow, fetches code for instructions, and controls how data moves around the system. Arithmetic and logic unit. The arithmetic and logic unit is that part of the CPU that handles all the calculations the CPU may need. For example, addition, subtraction, comparisons, etc. It performs logical operations, bit shifting operations, and arithmetic operations. So the second unit of basic structure is main memory. The accumulator stores the results of calculations made by the arithmetic and logic unit. It holds the intermediate of arithmetic and logic operations, and it acts as a temporary storage location or device. The program counter keeps track of the memory location of the next instructions to be dealt with. The PC then passes this next address to the memory address register. The memory address register stores the memory locations of instructions that need to be fetched from memory or stored in the memory.
Register MDR. It stores instruction fetched from memory or any data that is to be transformed to and stored in the memory. There are two types of register. First is current instruction register CIR and second is instruction buffer register. First, current instruction register. It stores the most recently fetched instruction while it is waiting to be coded and executed. Second, instruction buffer register. The instruction that is not to be executed immediately, it's placed in the instruction buffer register. IBA. This is the basic structure of von Neumann. Third, input-output devices. Program or data is read into main memory from the input device or secondary storage under the control of CPU, Central Processing Unit, input instruction. Output device are used to output information from a computer. If some results are evaluated by the computer and it is stored in the computer, then with the help of output devices, we can present them to the user.
In the von Neumann architecture, the address bus, data bus, and the control bus are used to facilitate communication between these components. Address bus. In the von Neumann architecture, the address bus is used by the CPU to specify the memory address of the data it wants to read or write. When the CPU needs to read data from memory or an input-output device, it places the memory address on the address bus and asserts a read signal on the control bus. The memory or input-output device then places the requested data onto the data bus, and the CPU reads the data from the data bus. Similarly, when the CPU needs to write data to memory or an input-output device, it places the memory address and the data onto the address and data buses respectively, and asserts a write signal on the control bus. The memory or input-output device then writes the data to the specified memory location. The address bus is unidirectional bus, meaning it transfers information in one direction only, from the CPU to the memory or input-output device. The address bus is typically made up of multiple wires, with each wire representing a bit of the memory address. Data bus. The data bus is a set of wires that carry the data between the CPU and the memory unit or input-output device. The data bus allows the CPU to read or write data to or from memory or input-output device. The width of the data bus determines the amount of data that can be transferred in a single clock cycle. For example, a 32-bit bus can transfer 32 bits of data in a single clock cycle.
When the CPU needs to read data from memory or an input-output device, it places the memory address on the address bus and asserts a read signal on the control bus. The memory or input-output device then places the requested data onto the data bus, and the CPU reads the data from the data bus. The data bus is typically bidirectional, meaning it can transfer data in both directions. This allows the CPU to read data from memory or input-output devices and write data to memory or input-output devices. The width of the data bus determines the amount of data that can be transferred in a single clock cycle. Control bus. The control bus is used to carry control signals between the CPU, memory, and input-output devices. These control signals specify the type of operation to be performed, such as read or write operations, and control the flow of data between the CPU and other components in the system. The control bus includes signals such as read and write signals, which indicate whether the CPU wants to read data from memory or write data to memory. The control bus also includes interrupt signals, which indicate that an input-output device needs the CPU's attention. When an input-output device needs the CPU's attention, it asserts an interrupt signal on the control bus. The CPU then stops its current operation and begins executing an interrupt service routine to handle the request from the input-output device. The control bus is an essential component of the von Neumann architecture as it carries control signals between the CPU, memory, and input-output devices.
So I am Aniket Kothawde. My roll number is 58. So now we will see the system buses. So basically the system bus is a pathway composed of the cables and the connectors, which are used to carry the data between a computer microprocessor and the main memory. So basically the bus provides the communication path for the data and the control signals moving between major components of computer system. As we can see that in the system bus, it consists of the three parts: control bus, address bus, and data bus. Now these three parts in this system bus is consisting, and this is connected to the CPU, that is central processing unit, memory, and input output devices. Now basically the system bus is a single computer bus. It contains basically the major components combining of the function of data buses to the carry information. Now this is an address bus. It determine where it should be the sent or the read the data. And the next is the control bus. It is used to determine its operation. Now this is a system bus. This technique was developed to reduce the cost and improve the quality. Now we will see its the functionality. Now the first of all, the data bus. It carries the data among the memory unit and input output devices and the processor. Now next is an address bus. It carries the address of data between memory and processor. And next is a control bus. It carries the control commands from CPU, that is central processing unit, in order to control and coordinate the all activities within the computer. So basically it's battery. These are some buses. It transmitted from one part of computer to the another part of computer to connect all the major internal components of CPU memory by means of the buses. So now these all are connected with each other by means of the buses. So that is the basic part of this. So now we will see its next part. So now, in addition to these buses, there are other components that makes up the on-Neumann architecture, such as the program counter, also the instruction register and arithmetic logic unit. So now the program counter. So basically, that program counter, it holds and next instructions of a memory. So that's the basic function of that program counter. Also, the R, that is instruction register, it holds that instructions that are going to be executed at the next time. And next is an ALU, that is perform arithmetic and logical operation data. So these are some functionality of program counter, instruction register, and arithmetic logic unit, that is ALU. So now, one Neumann architecture basic construction. So now, the computer consists of the four main subsystems. First is a memory part, next is an arithmetic logic unit, and third one is a control unit, and fourth one is an input output system. The von Neumann architecture is based on the store program computer concepts, where instructions data and program data are stored in the same memory. So now we will see some concept before we was in the address data and control buses. So now what is a control unit? So control unit handles all the processor control signals. It directs all input and output flow and fetch the code for instructions. And also it controls how data moves around the system. So basically that work is done by the control unit part. So now next is an MAR and MDR. So the MAR is known as a memory address register. It stores the memory location of instructions that need to be fetched from the memory or stored into the memory. Next is an MDR part. It stores the instructions fetched from memory or any data that are going to be transferred to the store in the memory. So this is an MAR and MDR. Next is an accumulator. It stores its data. Also the input-output interfaces to devices, input-output interfaces to the devices. So that is a connection between memory, input-output bus, CPU. So that interconnection is due to of the buses, like as address bus, data bus, and control bus. So that's all about the CPU and their interconnections of memory, CPU, and IO buses. So thank you.